Alright, time for another draftphysics.com video presentation. So we will deal with one of what are called the Bell inequality kind of experiments. And this one's the classic one, sort of relates to all of the initial experiments that had anything to do with entanglement were all based on light polarization. They called it something else a lot of times. They'll call it spin and all kinds of things. They'll pretend they're testing for some aspect of a photon when clearly they're just talking about its polarization. And in the case of polarization, we're partially talking about phase, because it's the phase that gets changed by the filter, and it changes the phases of the photons unequally. All right, so I'll play some of this, and then we'll go to the drawing board. I guess the preface of the statement made will be that the whole thing is sort of a big fake, in the sense that they say quantum mechanics predicts a certain outcome. It never predicted the outcome. Okay, it experimentally found out there was an outcome. It didn't seem intuitive. They decided, okay, well, it's a fact, it does happen this way, and then they do the experiment in some different way, where they claim the only way the experiment can be made sense of is because of entanglement and, woo and ESP and faster than light communication. When, yes, it can be explained, and it's exactly the same outcome. So it's like the entanglement experiment is just verifying the unentangled experiment. It's just finding the same exact result as the experiment you didn't complicate. So you do the experiment a simple way, you get an outcome. They do it a very complicated way, and they get the same outcome and claim, well, the only way it could come out with the same outcome is that the photons have to be entangled, because somehow they had to be entangled in the simple experiment when they weren't entangled in the simple experiment. Well, anyway, it's I didn't realize it was this big a fake. It's just another big fake, a big hypey fraud. I'll give you a simple explanation why, and that they use terms like hidden variable. There's not a hidden variable. There's a right in your face function that takes place that accounts for why in the first place there's this unintuitive result. Okay, I'll explain that.
90 degrees off from the first. What you're observing is that the photons with polarization that allows them to pass through a filter along one axis have a much lower probability of passing through a second filter along a perpendicular axis. In principle, zero probability.
Right, so why didn't you just say that instead of much lower? Okay, so we're just doing the bar thing, blah, blah, blah.
But here's where things get quantumly bizarre. All these filters do is remove light. They filter it out.
Okay, they don't filter it out, so that's just an assumption on their part. As I've sort of made the point, the experiment he's going to do right now proves the photons aren't filtered out. They're not blocked. They're not destroyed. All that's done to the photons is that somehow the photon is not in the same condition and will not be seen as a photon, and that you have to fix the photon again before it's a photon. So the energy is going straight through these filters. The photon, whatever it is, its essence is going right through the filter. And all you're doing is changing it enough so that when it hits a surface, it won't be a photon. You won't see it as a photon because it's been too distorted. But that's it. It never was destroyed. It was never stopped.
But if you take a third filter and orient it 45 degrees off from that first one, and then you put it in between the two, the lamp actually looks brighter.
Yes, that's right. More light gets through. So the very fact is the first and second filter can't be blocking anything because the third filter couldn't fix it then. There'd be nothing there to fix. So the fixer is fixing something that's broken, kind of obviously. So obviously the light is in a different state after it goes through the polarizer. I think obviously.
This is not the middle filter generating more light. Somehow, introducing another filter actually lets more light through. With perfect filters,
Now, see, this will be the really important part, okay? It's one of the important moments, okay, that just kind of proves the point of the not hidden variable.
you keep adding more and more in between at in-between angles, this trend actually continues.
There. So he's pointing out to you that I can make this work even more and more and more. So the more filters I add, the more light I can reclimate or get back. So he's clearly pointing out that the filters must be doing something to the light. There must be some effect. So when the light goes through the filter, the light isn't the same. Okay, it's been changed, and it can be changed a lot by each one of these filters, and you'll be able to get back more and more and more, recover more and more light. So therefore, the filters have to be doing something. All right. So the real point is when they get to the 50-50 argument. So that is here. Okay.
Explanation that might or
So they just keep talking about all these explanations for why there's a result, and clearly the explanation is the filters are affecting the photons. They're changing them. They're distorting them.
might not exist. And yet, we can do just that.
With sunglasses and polarization of light. Let's go ahead and lay down some numbers here. When light passes through a polarizing filter, oriented vertically, and then comes to another polarizing filter, oriented that same way, experiments show that it's essentially guaranteed to make it through that second filter. But if that's...
Alright, so that's again an exaggeration, because the filters do, they do break some photons beyond reclamation.
Second filter was tilted 90 degrees from the first, then each photon has a 0% chance of passing through. And halfway between, at 45 degrees, there's a 50-50 chance.
Right. Now the catch is, right, if they put these intermediate filters in, so instead of a 45 degrees, if they just go 22 first and then go 22 again, they'll get back 85%. So instead of being at 75%, they'll be at 85% if they use the two filter method. So they'll get back 10% more light if they use two filters, okay, half filters, quarter filters, you could argue. So if you put two quarter filters in, you'll do better than one half filter. Now that's a truth in a lot of cases, and it clearly indicates that there's an advantage where there's more chance of the light getting through the lower the angle. That is, more light gets through at this top than gets through at the bottom of that 45-degree angle. In the first 22 degrees, there's more photons going through than there is in the second 22 degrees. That's the simple explanation.
What's more, these probabilities seem to only depend on the angle between the two filters in question, and not on anything that happened to the photon before.
Right, so he says it seems. So there's no seems. You didn't do a test for that. So there's no, it seems the filter didn't change it. No, it's perfectly reasonable to say the filter changed the photons. There's no seems here. You didn't do a test for any seems. It seems. So they don't do the test, right? He didn't do the, well, what if we go 10% at a time and 10%, but oh yeah, that does work. So what it seems is if you actually test for it, that is, you put more filters in, you'll find out that, oh yeah, you can completely change the outcome by cutting the filters into pieces, okay, and moving the photons incrementally. That you do find a difference. So it seems the filters are affecting the photons,
including potentially having passed through a different filter first.
But the real numerical weirdness here happens for filters oriented less than 45 degrees apart. For example, at 22.5 degrees, any photon which passes through that first filter has an 85% chance of passing through the second filter. To see where all these numbers come from, by the way, check out the second video.
Right, so that 85 isn't 75, which you'd expect. 75, 25 plus 25 equals 50.
What's strange about that last number is that you might expect it to be more like halfway between 50% and 100%, since 22.5 degrees is halfway between 0 and 45, but 85% is significantly higher. To see
Yeah, and all that just means is instead of it being a straight line, linear, it's a curved line. That is, it's just like all the other curved lines. They have curved space, they have all kinds of curves that they have in all kinds of things, all kinds of parabolas, all kinds of... And somehow when there's one here, they don't get it. All of a sudden they're surprised. How could it possibly be a curved line? You mean more photons get through the less it's less angle, and the less get through at the bottom section? That's what the filters are exploiting. The 22-degree filter is exploiting the fact that more photons will get through that, okay, at 22 degrees than if you try to fix a photon at 45 degrees, it didn't work. So if you incrementally bend, it works. If you try to do it all in one big swoop, it doesn't work. You break too many photons too much. Breaking them a little works. Breaking them a lot doesn't work. That's really the moral of the story. All right, so I don't even think you need to play any more of this. I mean, you can do they have these little Venn diagrams kind of illustrating it, but this is the whole case. The whole case for this phenomenon is they're saying conventional physics, or the conventional notion, says the number should be 75. When, of course, the fucking experiment's showing it's not 75, it's 85, okay? If you do it incrementally, the number's 85. If you do it all at one swoop, it's not 85. I mean, it's not that hard to figure that out. All right, so might as well just get to the drawing. So we'll do this. See, it seems how slowly they do this. So they're just going to overlap these things and say, if it goes through this and it goes through that, blah, blah, blah.
Through A. Now, if you want to produce the results that you see in experiments, about 85 of these photons would have a hidden variable determining that they pass through B. So
a hidden variable that they pass through B. So he's saying the fact is that they have a condition, all right? You've now taken something that was oriented this way, and now you've oriented this way. And then you're going to orient it this way, and then you're going to orient it that way. And of course, it'll go through the filter then, because you're subtly changing its position through putting it through these different incremental filters that are capitalizing on the fact that you're doing it a favor. And so that's the part I'll explain. All right, that's probably enough. So they even say at one point in this video, well, one of our assumptions is that the filters don't change the photons. So obviously, okay, that's where the conversation should end, right? Because, well, have you proven that the filters don't change the photons? Because if the filters change the photons and your assumption is wrong, then the outcome is perfectly reasonable. And you don't need any woo particles. You don't need any ESP. You don't need any of this crap to explain it, but you can explain it because it's physically changing the photons. All right, so I'll get to that part. Just, I mean, they're so gung ho and woo hypey. 7 million views in this video, and it just has all these wrong declarations of the truth. They don't have evidence for what they're saying. There's no other explanation except woo. Of course, there could be an explanation. You haven't considered all the possible explanations. I would argue they haven't considered any, because, it hasn't taken me that long. I mean, I've always spent a couple of days really thinking about this bullshit, and I came up with an answer. All right. So to the answer. So I have argued, okay, that photons aren't what they claim. It's not a wave. It's not all that crap. But let's try to come up with some diagram of a photon that we can all agree on, okay? And the point is that I would argue that the polarization is in a physical dimensional polarization, okay? It's bits of energy. I'll call this a photon, okay? It's 3 little bits that have a frequency between them, all right? A distance between them, and they're also not aligned in space perfectly, okay? So they have a polarization this way that's the same or proportional to their wavelength here. All right, so they're just a little out of alignment, and then they're in space. So there's 2 geometric features they have. So with that diagram, so just grant me that diagram as a possible photon, and then what I'll be saying can make more or less sense to you. So let's say I put a grid, okay, the polarizing film, and we're just going to we're not going to deal with phase, we're just going to deal with the one feature, okay? And the feature is going to be that every time a little bit goes by a surface, it can be deflected a little bit up or down, depending on how it hits an electron. So the idea would be the surfaces have electrons, the little bit's going to hit an electron. The electron is either moving this way or it's moving that way, and the photon will be given a little change in its direction, because the electron is going to move in space, and that's going to create a new photon, blah, 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 blah. But let's just say the photon itself is scattered. Compton's scattering type event, okay? Photon meets electron, photon comes out at a different angle. Okay, so that's what's going to happen here. So it's going through the grid, and the grid is aligned this way. The bars are against it, so to speak, against the polarization. Well, the advantage of it being against the polarization is that you can sort of understand if this is my three little bits in space and they're going into the board, you can understand that if I hit the grid this way, they'll be bent up or they'll be bent down. Those are the two choices, right? Up and down. So they're going to end up on the other side misaligned maybe. Okay, we'll just use solid dots. They'll be in the wrong alignment, but they're close to being correct. It's close to being still a photon in the sense that all you've done is widened it a little bit this way in this dimension, but you haven't added any dimensionality this way. Now the inverse would happen if the bars are going this way. The bars are going this way and the photon's going through, then the bits that all are in one dimension are now going to be spread over here, and over here. They're going to be spread this way against their alignment, against their polarization. So the irony is these bars spread the photons against their alignment. The bars this way spread the photons with their polarization. So they're recoverable. That's the key word. So the first filter, the photons go through. They do this. That actually happens. They get broken. But for an awful lot of them, 45%, 48%, the fact is that if there's two photons, you know, this photon will throw a bit over here, and this photon will throw a bit down here, and this one, and they'll just end up remaking each other. They'll just end up going back in alignment because, you know, one from down here shot up and one from up here shot down, and they end up in the same place. So you're just basically filling a line, okay, with these photons, with these pieces, the elements of a photon, and you're just recovering the same lines. The same timed events are still happening. You've just changed which photon, what angle it's going at, which way is it traveling. This one's traveling that way, this one's traveling this way. And it doesn't matter how far out I go, they're still hitting the surface pretty much in alignment. They're in the same line. Like I said, you've made the line longer that they could possibly hit on, but you haven't made it wider, and that's the key factor. Wider would be impossible to put them back together. Up and down, it's really possible to put them back together, but you're all in this one narrow thing. So it's the difference between the area of this hitting this surface versus hitting this surface. This is a small area. This is a big area. Okay, so the photons are broken if they're all out here. If they're here, if they're being forced to be broken in this little area, then they're recoverable. It's a simple argument. And so that's what's happening with each filter. So you can sort of understand. I think I'll erase and continue. Alright, so the 22 degree number is really important to this. You know, it's half of the 45 degree, but you can sort of understand that that's the scope, okay, of these, you know, these areas that something's going to go through. So you're saying that all the polarizations, okay, that are in this line, okay, so that would be this one and this one and, well, I can't really draw them, but, you know, okay, there's a bunch of polarizations that are going to go into this film, and it's these that'll all survive the experience, and the ones here will not survive, right? So the ones that are, the ones that have an orientation this way, or this way, or this way, they won't make it, okay, because their bits are going to be flying up and down, and they're going horizontally. So there's enough vertical for these to all, they all have enough vertical component, okay, the polarization of the light is close enough to that perfect middle, right? The perfect middle, it goes through really easy. Everything bent a little means it's going to be a little bit off. And the further away, the further out you go, the more off the potential is. So the more crooked it gets, the further over you go. So you can understand that this would be the mean line, which would be, oh, that's a guaranteed, no problem. The rest of them are a little less than guaranteed, okay, because you're sending the bits wider, okay. They want to go, they want to stay on this line, and the more you bend the line, as I just pointed out, the more you're separating them in space this way. You want them this way. You want them to stay on this line. So the one on the right in the middle, everything stays on the line. Everything bent, okay, gets off the line more and more. So the idea is, well, if I put another filter in, okay, that's now just going to be bent this way, so it's tilted a little, 25 degrees, okay, and I put this new filter in at 25 degrees, you could see that everything on this side of the line is going to be really happy, because now it's even more lined up, right? It's already has an orientation that's to that new filter. So the new filter looks perfectly straight to it. It's not going to do any more bending up or bending. It's not going to do any, it'll do bending up and down, but it's not doing any side to side. So all the stuff on this side is a big winner. So this is what's causing your 85%, because these are all winners on this side. They all get through easy because you've bent the center to exactly their orientation now, which is a little bent this way. The ones on this side aren't going to do well at all. And like the one that got through that's way over here, he's going to have a terrible time. This is a full 45 degrees away from him. He's 45 degrees. This is 22 degrees. This is 45 degrees away. He's going to start getting bent a lot on the sideways motion. So he's getting ruined. All right. And so you can see if I move the filter again, the same thing happens, right? I mean, this half of these things are 100% sure to get in, and the other ones are going to get more and more bent. But the fact is now you're recovering some of the ones you broke in the original turn. So some of the ones you broke in the original turn, now you've caught up with them, and now you're putting a filter in that's going to get them back on that mean line again. So that's what's really making the change in the photon, is if you go incrementally, then you're subtly changing, off center, but you keep moving a little bit, you keep the center kind of close. And the more dramatic the change is, the more off you get, the more further away the photon bits are from each other. So you can minimize how much damage you're doing to them by distorting them a little bit at a time, and it'll only add up to whatever, 70% bending, when if you did it all at once, it'd be 100% bending. And so that's what's really making the difference, is how many filters you go through. Each filter makes some photons better, breaks some worse. So each filter does a little bit different thing to the total environment of photons, the total dot spread. So if you go a little bit at a time, you can keep the dot spread in here. If you go all the way radical, then the dot spread ends up out here. So it's really just about how much spread, how much scatter, how much real scatter you're creating. And you can change that, okay, by the extra filter. So add more filters, you'll rescue more photons. You'll prevent more photons from being broken catastrophically, where the pieces are way too far apart. They're way too spread to recreate photons. Alright, so that's probably enough of that. So the whole point is that it doesn't, okay, the 85%, that is 15% for the first filter, 15% for the second filter, okay, of photons you're getting, and it doesn't add up to the, that 30 doesn't add up to the 50%, okay, you got when you just did the radical change. So 30 isn't as many destroyed as 50. And you can sort of figure that, well, of course, but it makes sense because you used two filters here. And you didn't break the photons as catastrophically with each filter turn. The photons had were able to be reoriented subtly. I can't think of the right word to use for it. The density of their scatter, okay, was minimized here with the two filters. The three filters would make it even better, four filters even better. So they could just keep going in terms of running away from this 50% number, and they can keep getting better numbers the more filters they use. Except the only downside is you're losing 1% of the light per filter, just from the composite of the filter material. Might be even more than that, might be 2% even. I mean, I think the standard cheap ones are like 3 or 4%, so it's a lot of a degrade per filter. So all of your improvement would be destroyed by the fact that you have to go through more plastic. But in principle, Okay, the more filters, the more light you can recover. All right, so that's all it's about though. So it's just about a number, 75 versus 85. Okay, so they go into the experiment and we already know the right answer is 85. Okay, we know that's what you can get if you do it, the experiment. That's the number. And so why do they assume that we should be getting 75? When we know, no, we can get 85%. So they're creating a false outcome and then saying quantum mechanics saved the day with its entanglement theory. You don't need an entanglement theory. We already knew it from just using the 3 filters. We already knew the right answer by putting in the extra filter. Alright. I don't think there's anything more I need to say. So it is a little bit complicated, but again, I didn't realize that they weren't finding a new result. They were just saying, I'm going to separate the 2 filters. I'm going to take the 2 filters I'm going to use, the 22 degrees and then the 22 degrees. I'm just going to separate those 2 filters and pretend it's not the same thing as you've already put a photon through a filter and you already put a photon through a filter here. It's the same experiment. You haven't changed anything. By using 2 photons, you didn't change the experiment fundamentally. The photons both have a history, and the history is going to prove that the one that went through the filter is now ready to go through a second filter. If you didn't go through the first filter, you won't be ready to go through the second filter. If I put the first filter at 22 degrees here, okay, and then I do the experiment and instead I put the second filter first, that is, I put the filter that's doing 22 to 45, instead of the one going from 0 to 22, if I force it to go through this one first, it won't work. I can't go backwards. I can't bend the photons this much and then put the other filter in and fix them. I have to go, the steps have to be, this has to be the first step, the second step is another 22 degrees, the third step is another 22 degrees. You have to go by the increments and you have to start from 0. You can't start at 90 degrees and then put in a quarter wave or a 10th wave filter and reclimate the photons backwards. That won't work. Alright, that's probably enough. I mean, they make it into an incredibly complicated subject, and apparently it's, they have a fake argument that somehow rational physics says the number 75 when, no, rational physics accepts it's a curved line. That you can, there's more photons here that are going to go through than there are over here. There's a higher number in this 22 to 45 that won't make it than there is number of not makers here. More will make it here. If I was going to take the total and say how much, which one of these photons, all the photons in this piece of pie are going to make it through, I already know that 70% or 85% of the ones that are going to make it through are here. And I know for sure the ones here to here are going to make it through because I've tilted the second filter to make them perfectly line up. The second filter is basically guaranteeing that the ones that go from here to here are going to make it no problem. Alright. So, yeah, I think that's enough. I mean, like I said, it's probably just too complicated to make a decisive proof argument, but I'm just saying they're using the term hidden variable implies that the only argument people are making is some entanglement argument, when no, the argument is you don't even know what a photon is. And again, the simple argument is, well, maybe I'll just find that one clip where he says overtly, this is all based on the assumption that the filters don't change the photons. Alright, so this is just more diagrammic explanation, but the key point is said, so we'll just play that. And
photons passing A and blocked at C is entirely contained inside the previous 2. And yet, what quantum mechanics predicts and what these entanglements...
So just understand, quantum mechanics never predicted the 85% photon thing with the 2 filter thing. So it never predicted any of that. And now the prediction is made because we know the answer. So let's understand. So they can put in the formula that, yes, this is the new probability we learned. This is the probability. It's the factual probability. They never predicted the probability ahead of time. They observed the probability actually taking place. And now they're saying that prediction is owned by quantum mechanics. It can't be owned by any other logic applied, which is really just such a cheat.
Experiments verify is that a full 50% of those measured to pass through A should have an entangled partner getting blocked at C. If you assume that all these circles...
So here, if you assume circles have the same size, that's another word for the same number of photons, I suppose.
have the same size, which means any previously unmeasured photon has no preference for one of these filters over the others.
Okay, so any previously measured photon has no preference. So that just completely defeats the logic that you have to incrementally move the filters. If the filters aren't incremental, that is, you don't cascade them in the right order, if you put them out of order, it wouldn't matter. It does matter. So their assumption, okay, is wrong. There's no reason to make that assumption that it doesn't matter what filter order the photon is moving through. Of course it matters what order they hit the filters in. And if they're in the wrong order, then you won't get the same result. Because it is about what the filters are doing to the photons. It's not about photons communicating with each other. It's about filters affecting photons. If they want to argue something's entangled, they have to argue the filters are entangled, not the photons.
There is literally no way to accurately represent all three of these proportions in a diagram like this, so it's not looking good for hidden variable.
So again, they keep saying it's not looking good to be able to create an abstraction that we couldn't explain either. Of course, you can't explain it either because it doesn't happen. So again, you're arguing for an outcome that doesn't happen. The 15 and 15 don't have to equal 50 because they're two different ways of affecting the photon. It's two different physical events that happen to the photons. Moving them this and then moving them this is different than moving them from this to this. Those are different things. We shouldn't have the expectation that there should be some way to make it happen the other way. And conventional physics doesn't say it happens the other way. You're just saying that, well, 15 plus 15 should equal 50. No, it shouldn't, because we already know that the position of the filter matters. We already know it doesn't come out that way, and we know there must be a physical reason why it doesn't come out that way, why you're actually physically changing the photons. You're physically changing their proximity to each other by scattering them less each time, you're moving their angular difference. So by doing it incrementally, you keep them in a density that's different than the density they'll have if you just put them straight through this filter and then force them to go through this filter. That will create a different density. You'll spread the bits, 50% of the bits this way, and then this way you'll spread the other 50% that way, and therefore break all the photons. And if you do it incrementally, you'll keep all the spread within a limit. It's about as clear as I can make it, I think. Alright, so we'll call that an entanglement video and put it on the debate side and see what we get. But again, their argument is so false in the sense that it's such a straw man. They're straw manning rational physics by saying somehow there's no rational model of a photon, no reasonable model of a photon, where the photon is affected by the filter, and that you can explain why there's different results depending on whether I use 2 quarter filters or I use one full half filter. And yeah, there's a difference between a full half filter and 2 quarter filters. Okay, that's the simplest part of the argument. It can be made any simpler, and it really just depends on the fact that he understands a curved line. That they bend more the further away they are from the polarization of the filter, the more likely it are to not make it. And the closer they are to alignment, the more likely they are to make it. It's not a straight line. It's a curved line. All right. Mathematicians should understand that, frankly. It shouldn't fool them. All right. So anyway, till the next time and such, and so forth and whatnot. Yeah, I really think that's enough. Okay. So we'll leave it there. And till the next time and such. I'll just get the hell out of here. Might as well get rid of that also. So, till the next time, when we might talk about gravity. Who knows?